Good afternoon, everyone. It's such a great pleasure to be here. I'm Choi. Today I'm going to talk about some of the important perspective about A+P bidding. And as you know, A+P bidding is getting more popular, especially in urban district. Then A+B is commonly used together with the incentive, disincentive provisions. So the determination of a contract time and the road user delay cost is extremely important for the successful delivery of A+B bidding. Okay, here is a roadmap for my 20 minutes presentation for today. I will start by talking about some of the relevant background information, including some problems and challenges we now face. Then I will introduce the Californians bridge repair project as a worst practice example. In this project, the agency wasted $4 million for the incentives. Then, learning from the worst practice example, I have developed the 7-step procedure, new procedures. This is a new concept to determine the most realistic contract times and user delay cost for the A+B projects. Then I was lucky to apply this new concept to 5 different TechStart projects. Then I'm going to introduce one of the 5 projects as a best practice example. Then I'll wrap up the presentation. Okay. For my research purpose, I collected and analyzed the fairly large set of high confidence project data, over 6,000 project data from Florida. Then for the initial data analysis, I carefully classified all the 6,000 project data by the type of projects. And as you see here, look at this. 71% of all the 6,000 projects data fit into rehab project in 3R, such as rehab, reconstruction, then resurfacing. Then new highways, you see here, new bridges, then new highways, it takes only 4%. Then data do not lie. So based on this data analysis, we can conclude current highway construction paradigm has been changed from building new highways, building new facilities to 3R, rehabilitating, reconstructing, and then resurfacing the existing facilities. But however, the main problem is 30% of such rehab projects are in urban areas like Dallas, Houston, Austin, San Antonio. If you look at what's happening in California, 70% of such 3R projects are located in heavily populated San Francisco Bay areas, then LA metropolitan areas. And then this has created urgent dual challenges for us, which means we gotta close the lane to rebuild aging infrastructure. But at the same time, we gotta think about a way to minimize public inconvenience from traffic delays from lane closures. So there has been increased pressure to finish the project as early as possible to beat the clock. Then A+B with the ID incentive and this is incentive provisions. These are one of the ideas to achieve this aim for early project completion. Okay, in the next 2 slides, let me dive a little bit deeper into statistical analysis. As you see here, this is a very well-known time-cost trade-off curve. As you see here, as we're trying to reduce for example, reduce the project duration from this economic schedule to the normal schedule, say by delta T. What happened? Project cost increased by delta C. This is a very well-known concept for the time cost trade-off. So we can say, as we're trying to cut the duration of projects, we experience the project cost to be increased. Okay. These are the main concept for time cost trade-off. Then we can say there is a trade-off effect between the project schedule and project cost. Okay. Based on this time cost trade-off curve, look at this. Let me get your attention to this, the red dot right here in the center point. Look at this. These are our goal. These are the goal for any project on time and on budget project delivery. Then our goal is moving the curve from right here to the bottom left corner, this one. This is our ultimate goal. Then, based on this center point red dot, we can divide this entire area into 4 different performance blocks. Okay? So first performance block is any project fit into this category. This block is project was finished behind the schedule, under cost with the cost overrun. Okay. Second block for the by the same token, the late completion, then cost saving. This is the first performance block is a worst case scenario. Then, if you look at a performance block number 3, this is the actually best case scenario, which means any project fit into this category, performance block, the project was finished ahead of schedule under cost saving, best case scenario. So I selected 1,400 projects that utilize any of the alternative contracting methods, just like this. A plus B, ID, incentive, disincentive, and NEB, there's a no excuse bonus, then lump sum, and design bid build. Then, by utilizing the key performance indicator I developed, I carefully track the individual performance of 1,400 projects, just like this. As you see here, A plus B, if you look at A plus B, can you match the color? There is a heavy population for the A plus B. If you look at the green, which represents the ID projects, most of them heavily spotted in the performance block number 3. So let me give you a number. Okay. So if you look at the best case scenario, look at this. Then the ID project performed the best. Then followed by no excuse bonus, lump sum, then conventional A plus B is actually was the worst. If we look at a worst case scenario here, the performance block number 1, look at this. Which one is the worst? Absolutely, A plus B was the worst, then followed by followed by conventional lump sum, no excuse bonus, then ID. So, as I said, data do not lie. So this data analysis clearly shows A plus B has some critical performance issues, which is opposite to what has been commonly believed for the A plus B. Let's look at this. As you know very well, for the A plus B is, by the way, A plus B project is commonly used together with the ID provisions. For Florida, 100% of A plus B projects are used together with ID provisions. It's very common. Then in this A plus B ID contracting, the bidding mechanism, the winning bidder is the one who turns in the lowest combined bid for the A cost and the B for the time. Okay? Then, so that's why the determination of a contract time, the user delay cost, which it takes the B value of A plus B, is extremely important. Let me show you some worst practice example. Let's look at this. Okay. This is a part of the Interstate 580, which is called the MacArthur Bridge. Then this is the East Bay, home of 7 million people. This is one of the major commuting routes heading to the Bay Bridge to the San Francisco. Then, let me tell you more about this project. Then a truck driver, look at this, truck driver. Around 4 o'clock a.m., the truck driver just slept. Then he lost control. So a fully loaded gasoline tank truck is turned over. Because of fire, this small portion of an important bridge just collapsed. So what does that mean? 7 million people living in East Bay Area, including myself. Around that time, I lived in that the area just 5 miles away from this bridge for my Ph.D. study. Then bridge collapsed, so 7 million people they had immediate strong impact. For that reason, this project got extremely high attention from the media, the traveling public, then government. So for that reason, Caltrans, they decided to use the A+B ID bidding mechanism. Then for the B portion, Caltrans, they estimate 50 days with a record-breaking daily incentive amount of $200,000 each day, with $5 million as a maximum incentive bonus. The winning bidder was less than $1 million. And in the end, the contractor was able to finish the entire project within 25 days, and of course, he got the maximum incentive dollar amount of $5 million. However, in a post-construction investigation study, which I involved, the UC Berkeley professor, he found out that the realistic duration, project duration should be around less than 25 days. Then the total project cost should be less than $1.75 million. So going back to this bullet point, look at this. The contractor, he was smart enough. He expected that by a little bit manipulating this A portion of A+B, he strongly believed that he could get a $5 million just for free. Okay, so here's conclusion from this project. There is no justification for this project to cost more than $1.8 million, but the agency spent $5.88 million, 3 times higher than the realistic cost of the project. This was practice. The example clearly demonstrates the importance of a contract time determination and then load user delay cost determination. Learning from this worst practice example, I have developed the 7-step procedure to come up with, looks like this, to come up with the most realistic contract times and user delay cost for the A+B projects. And I was lucky to apply this new concept to 5 different Texas urban A+B ID projects. In the next slide, we're gonna just briefly go over each of the steps, just briefly, because the time is limited to 20 minutes. So this 7-step procedure begins with the identification of potential what-if scenarios. Okay, the options can be defined with respect to the duration and occurrence, such as nighttime, weekday, weekend, and 24/7. Each of option can be planned under 3 standard traffic control options, such as single lane closure, double lane closure, and the full lane closure with some variations. Second step is about PDE, project duration estimate. The effect individual what-if scenario has on project duration is estimated in this step by considering rehab strategies, pavement cross-section design. It could, for example, for the rigid pavement, it could be an 8-inch traditional conventional pavement cross-section design, or can be a long-lasting pavement design, 12 inches on top of an 8 inches cement treated base and project scope. Then, step number 3. In this step, we need to assess, evaluate the work zone traffic delay impact by considering various factors, such as value of traveler's time, $22 for the passenger vehicle, about $37 for the trucks, according to 2015 TTI report. Then 24-hour traffic count, AADT from Texas Lone Star database, and traffic lane configuration during lane closures, capacity adjustment based on highway demand capacity manual, the length of closure, lane width, number of lanes, percentage of trucks, etc., and etc. Then, at this point, we are getting 3 important decision-making data points, such as project schedule, user delay cost, and traffic delay. Okay. Then, next step number 4 is to select the best the most feasible options out of 3, out of 5, whatever they are, mainly based on contracting agencies' priority. If agencies' top priority is to, okay, let's just beat the clock. Our top priority is on schedule, project duration. Then select the fastest option. If agency would try to strike a balance between project duration, user delay cost, then level of traffic inconvenience to the traveling public, select the one accordingly. Okay. Then for the selected final option, then check all the potential risks, such as the public event. Will there be any the football game, for example, around the September? Then are there any public concerns? Also check any potential conflict, such as right of way, then utilities. Then step number 6, we probably need to adjust initially estimate duration of a project for the finally selected candidate by applying accelerated production rate. So it is quite reasonable to expect that for the A+B incentive projects, the contract need to make additional commitment. So he will use 15 to 20% more resources for construction acceleration. This, I believe, quite reasonable expectation. So how do we do this? I have developed a bunch of very easy to follow lookup tables. Let me show you one example. This looks like this. Okay, these are one of the 8 lookup tables I developed. So it's very easy to use. Then when I developed these lookup tables for the accelerated production rate, I considered all the important factors, such as the type of rehab strategies. It may be concrete, it may be hot mix asphalt, it may be milling and AC operator mobilization, blah, blah, blah. Then scope of the projects, payment design, then the duration and occurrence of lane closures. It may be a weekend, weekday, 24/7, or nighttime. Then production rate. So for example, let me give you an example. We're going to use the concrete CRCP rehab strategies to rebuild the 10 lane mile, the badly damaged highways using long life cross-section design during 55-hour weekend. Then for the concrete, select the concrete, then the scope of the projects, then these are payment design. We're going to use a long life payment design. Then weekend closure, select the table. Then under the normal production rate, the table said it will take about 15.6 times lane closures. Then we need 36 working days. After applying accelerated production rate, the project can be finished within 13.6 lane times of lane closures, then within 31 number of working days. So these are savings. Okay. So the last step is to convert the number of working days into the number of calendar days by considering the weathers, weekend, holidays, and any non-working days using the Texas spec manual. Okay, as I said, I was lucky to apply this new concept, 7-step, the CTD contract time determination procedure to 5 different TechStop projects. Okay, I just picked this project as a best practice example. IH-20 Dallas project. The project scope is 6 centerline miles for 3 lanes for both directions. So 6 times 3, 18, 18 times 2, and 36. That is the project scope. And on the pull laps, 13-inch CPCD. Then the work zone has about 55,000 AATT. One unique thing about this project is the work zone has very, very high truck percentage, 27%. Then the agency want to use A+B plus ID. Then agency set up the $4,000 as daily incentive, disincentive bonus amount for 270 days. So the agency estimate 207 days. Okay. Then step number 1. In a pre-construction meeting, I asked the project team, hey, what do you want? What do you want to explore? Then they said, we want to explore these 2 things, weekday and nighttime. Then step number 2, project duration estimate. Okay. Based on the schedule estimate, the weekday is supposed to take 5,000 hours, working hours, then compared to the 22,000 hours by the nighttime. Then step number 3, we calculate the load user delay cost for weekday about $8,000. Then traffic delay impact. Then at this point, we got 3 important decision-making data points such as project duration, user delay cost, then traffic delay impact. Okay, then step number 4, we checked all the potential. Step number 4, we select the weekday as the final candidate because it was very easy decision-making, because weekday is just stood out in all 3 evaluation criteria. Then step number 5, we checked all the potential, the risk. Okay, we adjust the duration by applying production layer lookup tables. Okay, here are our recommendations for the contracting agencies. We believe the 270-day estimate by the contracting agency is too overestimate. So we recommend 210 days instead of 270 days. Then, if the agencies just stick with the 270 working days, what does that mean? This will result in almost $250,000 free bonus to the general contractors. Contractor will get it for free without making any additional commitment. Then for the daily, based on the estimated daily load user cost, we recommended $8,000 to be the daily incentive, disincentive amount. So the agencies, they listen our recommendation. They changed the number of working days to be 210 days from 270 days. Then daily incentive to $8,000 to properly better motivate the contractor for the projects. So with that, let me conclude. With that, I would like to thank you for your participations. Then I'd like to emphasize the importance of A+B contract time determination and then consequence it has on the outcome of the projects. As you see here, for the Caltrans Bridge repair projects, agency wasted $4 million just for 25-day projects by significantly overestimating contract times. For the textile projects here, the contracting agency, local district, was able to save $250,000 even before project begins. These 2 worst practice and best practice examples, I believe it clearly demonstrate the importance of time, cost, traffic integration like new approaches with the 7-step procedures.